Okay, so after your discussion, so I hope you discussed, and if you were incorrect at the beginning, now you know the correct answer. So this number measurement will have 3 sig fig, okay, because the 0 follows the decimal place, and this measurement it can have 4, it can have 3, it can have 2 sig fig, and it all depends how we will change in scientific notation. So which is 1.3 times 10 to the third meters. So for our calculations, we will always drop those zeros and consider them insignificant. But if you do measurement and you know that the instrument that you have were able to measure up to the third decimal place to the right, so then you have to claim it as a 1.30010 to the third and consider this as significant figures also. Okay, so I hope this review helps, and if you still have some questions, you're welcome to mail me or ask your classmates for clarification. So how to operate with sig fig? This is important. The major rule is I stated the major rule up here, that in your result, when you have measurements and you need to do any calculation, addition, subtraction, multiplication, or division, the result that you will get cannot be more accurate than the measurements from which it came. So what it means, for example, in addition and subtraction, and there are 2 different rules for addition subtraction is rule number 1, and for multiplication and division there is rule 2. Okay, so for rule 1, addition and subtraction, if we have the figure A being 3.00 meters and the width B is being 2.0 meters. So if we have to add these two numbers or subtract, okay, if we have to do A plus B to get the result, or if we have to do A minus B to get the result. So if we add 3 plus 2 is 5. So, but because it's physics, we have to claim the correct number of sig fig. So in this case, it will be 3 plus 2 is 5. And then we need to decide how many decimal places to keep. So the number of decimal places to keep, it's the least number of the decimal places in the measurement. So the least number in this case is only 1. So it's going to be 5.0 meters, and that's the correct the answer was the correct number of sig fig. Okay, so in this case our result it's not more accurate than the measurement that it came from. If we have to subtract, we follow the same rule. 3 minus 2 is 1, and then what we have to pay attention is to the number of decimal places, and for addition and subtraction we have to claim the least number of decimal places to one of the measurements. So it's 1.0 meters. So I want to emphasize when we add or subtract numbers, what we're looking for is how many numbers are after the decimal point. So we have to claim the least number of decimal places. So if we have exactly the same measurement and to do calculation, we have to multiply or divide them. So in this case, we have to, the result will have the least number of significant figure altogether. For example, A times B or A over B. A times B is 3 times 2 is 6. And then the least number of sig fig altogether is 2. That's why we'll claim 6.0 meter square. So it's important to keep unit also. Okay, so 3 divided by 2 is 1.5, and I don't have to add any more decimal places because this is 2 sig fig, and that's the least number of sig fig altogether. And meter over meter is cancels out, so we don't have any unit here. Okay, so the major difference, multiplication or division, we claim the least number of sig fig altogether. Least number of sig fig that one of the measurement contain. Okay, and when it's addition or subtraction, it's the least number of decimal places that one of the measurement contains. Okay, so there is a worksheet that you have, okay, and add or subtract the following measurements and multiply, divide. So I'm going to do one example from each, okay, that we can see how it works. So before I do examples, okay, I wanted to look through the list of the examples and tell me what is the major physics inaccuracy you can find here. So what is very inaccurate and what is the cannot be acceptable in physics. So when you look at these numbers, so what is missing? What important information is missing? That's my question. What important information is missing in these 3 examples and in these 4 examples? And I can tell without that information, me or you won't be able to do any calculations. So think about it and share your answer with the class. Okay, and then you probably need to pause. So in this case, if you didn't come up answer yet, so pause. Okay, I hope you discussed and I hope one of you were able to figure out that units, okay, the important information that it's missing here, units. And without units, we won't be able to do any calculation here. Okay, to fix that, okay, I'm going to add units here. So this is meters, and this is centimeters. Okay, so in this case, to do the calculations, okay, so before we do any calculation, we have to have the same unit. So which means we have to change this number 9.815 centimeter to meter. Okay, so I hope you're doing faster conversion now. So you can use a conversion factor, but 9.815 centimeter, it is actually 0.09815 of a meter. So I'm going to retype it real quick, 7.623 meters plus 85 meters plus 0.09815 of a meter. Okay, so now we can do the addition of this and we will have our 85. So you can do it, and I will do it quickly too. I hope you can do it without using calculators. So the result that I got is 92.72115. Okay, and it's in meters. So this is not correct number of sig fig. So now I'm looking for my measurements and I can see the least number of decimal places is 1. So all I have to have is only 1 decimal place in my number, in my answer. So 92.7 meters. So I round it down because 2 is less than 5. Okay, so right here I'm going to put the measurements and you will need to finish calculations. These are all in kilograms. Centiseconds, and this is seconds. Okay, so multiply or divide, the same thing, it's important to have units. Okay, and I want to emphasize what is also important, that we can add meters in centimeters, but we cannot add meters in kilograms. When we multiply, we can multiply different units. Can be in meters, can be in kilograms. Okay, so can be kilogram, and can be meter cube. Okay, so this is meter, and that has to be, because we're adding, has to be meter square. And the last number will be seconds, and this has to be, it's division, so that can be meter. Okay, so I'm not going to do calculation, but I can tell you that the first number, the least number of sigfig in first number is 4, and this is 4. So the result will have only 4 sigfig. So if I look at the example number 3, after I multiply, okay, I will keep all the numbers. You don't have to use the rule of significant figures. Yes, you keep all the answers, all the numbers, and when you add, you follow the rules of addition or subtraction, so you will have to keep the least number of decimal places. Okay, so work on this assignment, and I will provide the key, or we can ask Miss Ross. I'm sure that she knows this concept. And she will be able to help you. Okay, so on Monday, so you need to finish that worksheet about accuracy and precision, and you will have more practice about calculation with significant figures. So, and also there is an assignment to change the scientific notation. So this is what you will also do on Monday if you don't have time today. Okay, have a great weekend, and I will see you on Monday.